What the human eye and black holes and cameras all have in common is that they absorb light through lenses and the equivalent thereof, respectively. And I don't think it is out of the question that we exist in a biomimetic universe, and black holes might be the equivalent of machine eyes of some kind, and or camera lens structures of some kind. Especially when we consider these comparisons of the dynamics of black holes with the dynamics of cameras, both of which are machines that are absorbing photons, with black holes playing the roles as what are called far-field lenses, with their respective sizes having everything to do with how much light and other radiation they can absorb. Just like the apertures in these camera lens structures you see here. And our Milky Way galaxy is supposedly full of black holes that are organized like these cameras in these omnidirectional 3D camera arrays. And there are no two ways about this, as we can see with our own eyes. Here are some more comparisons of the structure of black holes with cameras and their lenses. And this includes telescope lenses, which more or less appear to be structured like the funnels of black holes, which, as already noted, absorb photons, just like a camera lens aperture, with sizes that vary according to applications, just like the sizes of black holes also vary. I think that black holes play many roles, and some kind of lens apparatus is just one of many roles that black holes play as part of some kind of observation platform. And as you watch this video, bear in mind that I am aware that there is a lot of junk science in this video, plus other of my Technoverse videos, but I think beneath this junk science resides kernels of truth. So if black holes are indeed some kind of far-field lenses or zoom lenses of some kind, then logic would dictate that the moon and the rest of the planets and moons would be near-field lenses of some kind, perhaps. Especially when we compare their internal structures with each other's, with the Earth and other cores of the planets and moons being somehow inverted, opaque, and more sophisticated beyond the imagination, with no need for the types of internal moving and transparent parts like the lens structures as we understand them, like these examples here, with the Earth and the Moon and the rest of the inner and perhaps outer planets working together as near-field lenses as well as sensors and so forth, with ourselves being the target specimens, perhaps. Sort of like these examples here, as small parts of what appears to be some kind of gigantic shape-shifting spectroscope merged with a microscope array, not unlike these microscopes and spectroscopes that you see, that abstractly mirrored the dynamics of our solar system, especially when we consider that the moon and the planets at large are shifting around the Earth and ourselves day and night, not unlike the lens and mirror and sensor arrays in these spectroscopes and microscopes with many varieties and applications. The same could probably be said of any of the trillions of solar systems in our universe with a sufficient number of planets and moons to form what would be an imaging system that defies the imagination, with the planets and moons that produce life automatically being target specimens in this system, which is largely based on some kind of fluorescence microscopy, I believe. And I don't think that it would be too much of a stretch to assume that the geochemical composition of the inner and outer planets have something to do with their coloring, not unlike the coloring of these fluorescence microscope color filter wheels, which are used for multispectral analysis of cells. We can also see how the circular organization and numbers of color filters in their respective wheels are abstract mirror images of the orbital organization of the planets in the solar system, always in the glare of the sun, except when they are eclipsed by other planets and moons in their respective orbits around the sun and each other, as they respectively pass in orbit by their neighbors and the earth, in seemingly mindless cycles determined by nothing more than the mindless laws of Physics 101. Let us begin this next section by bearing in mind the concepts of near and far field lenses, while we once again compare the dynamics and structure of the planets in our solar system with the structure and dynamics of these far and near field lens structures I picked at random out of many that are respectively used in microscopies, spectrography, photography, astrophotography, and so forth. And I think the cores of the living planets and even the moons might be some kind of electromagnetic hyper 3D lenses unto themselves, among other roles, perhaps. And if you are operating a small phone or tablet screen, then most of the clips in this video will not be discernible. And with no regard for size, scale, or the junk science involved in these comparisons, let us for now superficially focus on the pretty psychedelic coloring of these chemically doped lenses of all kinds, plus lens color filters with lots of different applications. This includes standard and telephoto zoom lenses, as well as telescope lenses, including space telescopes, and more lens filters, as well as lens filter material for cameras and telescopes and microscopes and so forth. And the chemistry of colored glass, including optical lenses, I presume, involves the use of naturally colored iron, copper, manganese, nickel, sulfur, plus other elements that are relatively abundant in the inner and outer planets, and that have something to do with the coloring of these planets. This ties into the fact that the coloring of the lenses and lens filters you see here has everything to do with what this equipment is used for, including for use in daytime or nighttime imaging and photography, or for thermal, visual, multispectral, and hyperspectral imaging, and so forth. To keep the ball rolling, I am going to data burst some of this material because the pictures speak for themselves. But it seems we have three choices of what to believe as far as the universe. We have the magical universe, which is the theological universe. Then we have the nihilistic universe, which is the universe that scientists and atheists like to cling to. And then we have the cybernetic universe, which is my vision of the universe. And I don't think it is less realistic than the magic vision of the universe, or the nihilistic vision of the universe. I believe the universe is a piece of technology. I believe we are technology. I believe the universe is a technological artifact that defies the imagination. Some kind of observation platform for life forms that become sentient in the universe, perhaps. But the solar system, I believe, is more likely than not to be a hyperspectral imaging system of some kind, which includes what is called broadband photometry, with the gas giant outer planets playing important roles as they absorb and perhaps deflect light from distant stars as well as from our sun, plus light reflected off the Earth and the rest of the inner planets, the moons, and even each other. Without losing our focus on the pretty colors of these comparisons, we are now moving into an area where we are comparing the gas giant outer planets to equally colorful digital camera imaging chips. And although some of the pictures of the gas giants are spectrally enhanced, there is no denying the similarities in colors between the gas giant planets and these digital imaging chips, which are semiconductors that convert photons to electrons and analog signals to digital signals that can be stored digitally in cameras and on computers and in the web and so forth. Even the inner planets could be considered digital imaging chips, which are gradually replacing camera film, including DSLR and CCD and CMOS chips, which respectively stand for digital single lens reflex, charged coupled device, and complementary metal oxide semiconductor. For the last 20-something years, these rapidly evolving chips have been finding their way into microscopes, telescopes, and cameras. The coloring of the planets, especially with regard to the gas giants, look like digital imaging chips, except for being round. And this includes their pretty bands of dust and gas that are swirling around the gas giants. And bearing in mind that the atmospheres of the gas giants are largely made of helium and hydrogen, scientists have recently invented CMOS imaging chips that are embedded with hydrogen and helium because these elements reduce the blooming effect, therefore enabling them to produce higher resolution images than other chips. Helium and hydrogen are also abundant in the atmospheres and crust of the inner planets as well, in addition to being present in the crust of the moons in our solar system. As we move into this next section, and bear in mind that the inner and outer planets around the Earth appear to be digital imaging chips, we must note how these planets are always hovering nearby the Earth, not unlike an observation or spy satellite network of some kind, with the gas giants playing their roles, whereby each of the gas giants is probably charged with picking up a specific electromagnetic frequency, either from Earthlings perhaps, or from other stars, including visual, thermal, radio, magnetic, infrared, and all the rest of the frequencies. And I included these comparisons of the gas giant planets with these multispectral sensor arrays and pods for no other reason than to highlight the similarities in the pretty colors between the gas giants of our solar system and the high-tech sensing and imaging and other optical equipment. We can see the striking similarities in coloring of the sensor nodes on these arrays and pods, and I would bet every penny I don't have that the chemical composition of these sensor nodes is nearly identical to the chemical composition of the planets in our solar system, especially Jupiter, Uranus, Neptune, and Saturn. This, I believe, could apply to other gas giant planets in the universe, such as those in the Kepler region of space that I included. The gas giants and the rest of the planets perhaps could also be compared to these optical diodes, again with a focus on the pretty coloring. Optical diodes do nothing more than turn light into electrical current. This is the result of light from an emitter bouncing off an object and being reflected into the detector diode / sensor, which are used for a wide range of medical and industrial products, some of which we have already looked at. Optical sensor slash receiver slash pickup diodes come in quite a few shapes and colors, and we can see how the external and internal structure and dynamics of these diodes are virtually identical to the structure and dynamics of the gas giant planets, including chemical compositions. And scientists have recently merged CMOS chips with photodiodes, which are structured like the outer and inner planets. These similarities include their geological and atmospheric layers and the sequences thereof, which are structurally identical to these digital imaging chips, more or less. In addition to interacting with light from the sun, like digital imaging chips and other optical equipment interact with an active light source of some kind. And all of this talk of optical diodes brings us back to black holes, which appear to in part be serving as some kind of digital imaging chips merged with photodiodes like these here, including infrared receiver diodes, plus diodes that play dual roles as receiver and emitter diodes, which emit and receive signals simultaneously, just like how black holes are receiving and emitting all kinds of radiation simultaneously, including infrared and other types of radiation. This dynamic is the same dynamic as the emitter-receiver systems in any number of optical biosensing and computing and other technologies that have been on the market for the last few decades, all of which are manufactured with lots of silicone, and silicone is abundant in the planets and moons and probably black holes and the suns as well. And this brings us to the fact that the suns appear to be playing their obvious roles as the ultimate emitter of light and other forms of soft and hard radiation that is used in biological imaging equipment, as well as any number of other consumer and industrial products that use optical diodes and laser diodes and cathodes and so forth. The same could be said of any number of trillions of suns in the universe, all of which are partially made of silicone, like some of these light-emitting diodes. This means that the suns, like our own, appear to serve as light-emitting diodes and or lasers that are working in tandem with optical receiver diodes in a spectrographic relationship that brings these optical sensors into relevance that you are looking at now as just another set of consumer and medical and industrial products. This includes a line of related products called surface plasmon resonance biosensors, which are based on a sensing technique called surface enhanced spectrography, plus other techniques we are or will be glancing at briefly as we notice how the interactions among the Earth, the Sun, and Moon are abstract mirror images of these surface plasmon resonance biosensor chips and microsphere biosensor resonators, whereby the Moon would play the role as optical receiver or detector or sensor diode or lens or related role relative to the Sun's role as light-emitting diode and or laser or infrared transmitter or something to that effect. This dynamic, as previously indicated, could apply to any of these devices that I am showing you in no particular order at this point, and many of them are not adequately labeled, if at all. All of these devices use one form of spectrography or another, and the more abstract and very simple similarities between the structure and dynamics of our solar system and these simple receiver and transmitter diodes cannot be discounted, especially when we factor in the chemical similarities between these devices and the planets, moons, and even the suns, plus the high probability that their respective chemical proportions are also similar. And as we move into the next section, bear in mind that these microscope and spectroscopes we see here all use some kind of digital imaging and optical sensor chips and diodes, including CCD and CMOS and related chips and diodes, some of which we have already seen and compared to the planets and our moon. These pictures of these particular microscope and spectroscope setups I picked specifically because the types of digital sensor chips and their cameras are clearly labeled for us to see, including with regard to their organization around their target specimens. Not unlike the moon and the outer and inner planets are organized around the Earth and ourselves in a roundabout way, but much farther away. And we must also not forget that the geochemical and atmospheric chemical composition of the planets and moons contain the basic elements that these digital chips are made of, and vice versa, including lots of metals and silicone and their respective oxides, the latter of which is basically sand and quartz, plus other crystals which are abundant in the planets and moons in our solar system, including the Earth. There are many widely fluctuating calculations out there on the internet as to the exact proportions of silicone and metal elements and their respective oxides and so forth that are found inside the Earth and the other planets. But from what I could guesstimate using any number of sources, and using the Earth as an example, the Earth is comprised of around 20-something% silicone, including silicone oxides, plus around 30-something% iron, including around 10% iron oxide, plus 15% magnesium, plus a few percent or percent of nickel, aluminum, titanium, copper, gold, silver, and so forth, plus all the metal oxides and rare earth metals that probably exist in the same proportion as in electronic equipment of virtually any kind, including biosensing, imaging, and computer and communications equipment. And this includes spherical semiconductors like these here that are now or will soon be mass-produced by the tech companies. And with Earth being the only example I will use, it seems the Earth is in part a CMOS digital imaging semiconductor chip merged with what is called a microfluidic lab on a chip, which is a chip-sized mini biological sensor for microscopic analysis of cells and DNA. The same elements these chips are made of probably exist in the same proportion in the inner planets like Earth. The Earth is in part, and more specifically, I think, a spherical microfluidic lab on a chip biosensor of some kind, with some kind of built-in camera lens, kind of like these examples. Over 70% of the Earth is also covered with water, which is consistent with my Earth as a microfluidic biosensor theory. The Earth and the rest of the planets and moons are not cotton candy floating in space like meaningless rocks and dirt. Let us not play games, and let us focus on the interior dynamics of the Earth compared to ourselves. This is what we would be looking at. The core of the Earth, the layers of the Earth, have all the trappings of the sensor technologies that you see here. We are being analyzed and scanned, I think, from the interior of the Earth, not unlike this lab-on-chip platform that we see here. And when we bring in the sun, this changes the equation to what is called optical fluidics or optofluidics or something to that effect. And this includes a lab-on-chip platform. But because the Earth is not flat like a chip, and because the Earth is round, then what we have is some kind of optical magnetic microsphere resonator platform. Some of these devices are called laboratory-on-chip microsphere biosensors and are based on a sensing technique called cavity-based spectrography and sensing. They are a mirror image of the Earth in its relation to the sun, and that's not even the half of it, but they are just another set of tools used by doctors and scientists to detect and analyze cells, DNA, nanoparticles, and other matter at the microscopic level using the forces of light as analytics, excitation, and manipulation agents. Some of these microsphere biosensors are specifically referred to as optical and or dielectric and or magnetic microsphere spectroscopes, and the dynamics of these devices are near mirror images of the electromagnetic relationships between the Earth, the Moon, and the Sun. And the electromagnetic relationship among the Earth, the Moon, and the Sun, especially with regard to the twin forces of light and magnetism, respectively, are more or less identical to the relationship of laser emitters and optical sensors relative to the target specimens inside these optical and or magnetic biosensor resonator spectroscopes. And some of these microsphere biosensors are also constructed in layers, just like the Earth is layered, as well as made of the same elements as these microsphere biosensors that you see. These microsphere biosensors rely on a biological sensing technique called optical and or magnetic resonance and light scattering, which are dynamics that play out in Earth's atmosphere and elsewhere in relation to the Sun, with light scattering dynamics between the Sun and the Earth being the same exact language used to describe the light scattering biosensing spectrography technique called Raman and fluorescence scattering, including Rayleigh and fluorescence scattering, plus other types of spectrography. These microsphere biosensors use optical fibers as what are called waveguides, whereas Earth's Schumann resonance field also acts as a waveguide and the equivalent of a resonance cavity, not unlike these examples here with the optical waveguide for this dielectric optical microsphere biosensor. What we have here is a scenario in which the dynamics and language of microsphere biosensor physics and the physics of earth science are bleeding into each other. This includes words like magnetic and optical resonance and Raman and Rayleigh scattering, fluorescence interactions and absorption, waveguides, resonance cavities, bandwidth, dielectric spheres, electromagnetic fields, and so forth. The fusion of the dynamics and language of biosensor physics and earth physics extends to radio physics as well, because it seems that the Earth and the other living planets and moons are spherical dielectric antennas of some kind, like these here, with their optical fiber or cable waveguides. The Earth and the other living planets are also layered like these spherical antennas, and their relationship to the Sun render them some kind of dielectric lens antennas merged with dielectric microspheres, perhaps, like the Earth, the dynamics of which I will not elaborate on any further. But Earth is a fusion of many technologies, and this assertion is supported by the fact that the geochemical composition of the Earth is comprised of the same elements as the technology you see in this video, in addition to being structured like the technologies we see here. I am going to end this video by saying that I have other videos out there under Cybernetic Universe, and if you like this video, subscribe, give it a thumbs up, and leave questions or comments.